Welcome back to the Deep Dive. So today we've gathered a set of sources directly from Confluent. We're looking at updates and some insights they put out between late April and mid-May 2025.
That's right. And the plan is really to, unpack the key stuff here. We'll look at platform developments, Confluent Cloud Services, but also their take on bigger picture things like data streaming, AI, even work culture, but only based on the specific material we have in front of us.
Yeah, our goal is just to pull out the most important bits. Help you get informed quickly on these particular Confluent updates and ideas without needing to read everything yourself. A bit of a shortcut. Okay, let's dive in. All right, first section. The core product and platform updates. There are a couple of interesting things they've announced in this time frame.
Definitely. One that caught my eye, especially for folks using Azure, is the release of their managed V2 connector for Apache Kafka for Azure Cosmos DB.
Right, so the basic idea is moving real-time event streams from Kafka straight into Cosmos DB, yeah. What's the practical benefit there?
Well, it's really about enabling certain kinds of applications. The sources mention it's key for building low latency apps, things that need to react fast, and also for live analytics directly on that incoming data. Plus, seamless cloud-native integration within Azure.
Okay.
So the insight, I think, is it smooths the path for using Cosmos DB's strengths, like its global distribution, with real-time Kafka data, removing some integration friction.
Got it. Simplifying that real-time flow into a major Azure service.
Yeah.
Okay, shifting slightly, but still on the platform side. News about the next generation control center for the self-managed Confluent platform. What's the story there?
Yeah, they've apparently done a big refresh. The main focus seems to be on user experience and performance.
Performance, how?
Well, the sources call out a much better UX overall, faster performance generally, but specifically they mention a 5x faster startup time for Control Center itself.
Oh, wow. 5x faster startup. That actually sounds pretty useful for anyone running their own clusters. Anything else?
They also mention more metrics available for monitoring and better scalability for Control Center. So while the faster startup is nice and concrete, the real takeaway for platform users, especially as their Kafka environments grow, is probably the better monitoring and scaling. It helps manage those bigger, more complex setups, reducing operational pain, basically.
Right. Makes sense as things get bigger. Okay, let's switch over to the cloud side. Confluent Cloud had its Q2 2025 updates. Was there a main theme?
Yeah, the headline they used was bringing together the best of batch and stream processing.
That sounds ambitious. How are they actually doing that? What features support that theme?
Two key things highlighted were adding Tableflow support for Delta Lake tables specifically, and also enhancements to Flink snapshot queries.
Ah, Delta Lake. Okay.
Exactly. So it looks like a clear move to make the output of streaming data easier to access and query for more traditional analytics, kind of bridging that gap between the real-time stream and the data lake world.
So looking at these together then, the Cosmos DB connector, the better control center, these cloud Q2 features like Tableflow for Delta, what's the connective tissue?
It's interesting, right? They seem to be hitting different user needs, but all pushing this core idea of making data in motion more practical, more integrated. For the self-managed folks, it's about operational ease, like we said. For cloud users, it's about plugging seamlessly into other big data ecosystems, Azure, Delta Lake, and making stream outputs easier to actually use for analysis. This whole batch and stream integration idea, supporting formats like Delta and Iceberg, means streaming isn't just for immediate reactions anymore, but also for historical analysis right alongside your batch data.
Okay, let's pull back a bit from the specific features. These sources also talk about some broader trends and even workplace culture. Let's start with the 2025 data streaming report findings they mentioned.
Yeah, the big takeaway highlighted there is pretty clear. IT leaders are really prioritizing investments in data streaming platforms. It's becoming a top focus.
And did the report give a reason why?
According to the source, yeah. It's fundamentally about unlocking the real value of their data. They see these platforms as the essential plumbing needed to actually use data in real time to, drive business decisions and outcomes.
So reinforcing that data in motion idea, but at a strategic level. There was also that piece, kind of different, about building a better asynchronous culture.
Right. That one looked at ways to help teams collaborate effectively when they're not, all online at the same time or in the same meeting, making async work.
What were the benefits they pointed to for doing that?
The sources suggested it could really help with things like reducing employee burnout, maybe boosting productivity, and making distributed or hybrid work models actually effective, not just well, functional. It's about setting things up so people aren't constantly blocked waiting for someone else.
Okay.
And, if you connect these two things, the focus on data streaming tech and this focus on async work culture, they both kind of tie back to this idea of organizations trying to innovate and win in a digital-first world. Real-time data is key for digital innovation, obviously.
Right.
But you need effective collaboration to make that innovation happen, especially if your teams are spread out. So it raises this interesting question, which the sources touch on. How does the tech, like streaming platforms enabling real-time data, influence, or even demand changes in how teams collaborate? And flip side, how does moving to async ways of working maybe change what you need from your tech stack so information flows and work gets done without everyone needing to be live?
Yeah, that interplay is fascinating.
Okay.
And another theme that definitely pops up multiple times in these sources is AI, specifically the connection between AI and event-driven architectures.
Oh, yeah. It's a big focus. There's one piece offering a framework for actually getting started with AI projects.
That's the 5 steps to building with AI. 1, using the RICE framework.
Exactly. RICE, reach, impact, confidence, and effort. The suggestion is you use this to evaluate potential AI ideas. You score them on, like, how many people it affects, how big the impact could be, how confident you are you can actually pull it off, and how much work it'll take. The goal is to just make more objective choices about which AI projects to tackle first, balancing those factors.
A practical prioritization tool.
Cool.
But they go further, right? Making a pretty strong claim that the future of AI agents specifically is event-driven.
They really hammer this point. The argument is basically for AI agents to go beyond simple tasks and become genuinely autonomous, adaptive problem solvers that can scale in an enterprise. They need to be fed by streaming data through an event-driven architecture, or ADA.
Why? Why is ED so crucial?
Because static data or batch updates are just too slow. Agents need that real-time context from events to react instantly to changes or new information. EDA provides that constant awareness and responsiveness they need to operate effectively.
Okay, so if you need responsive agents, you need VA. That naturally leads to talking about building multi-agent systems, right?
Yep.
Where one agent isn't enough.
Exactly. The approach laid out in the sources is about breaking down complex problems into smaller, specialized tasks. Then you have multiple agents, each handling a piece, working together like a team. It's about modularity for complex workflows.
And they mention specific tech for building the coordination layer for these agents.
Yes, they highlighted Apache Flink, which is for stream processing, and Apache Kafka, the event streaming platform, used together to build what they call a multi-agent orchestrator. Flink handles the processing logic, and Kafka acts as that reliable message bus between all the agents.
Right, Kafka is the communication backbone. There was another piece that tied this directly to Google's agent-to-agent protocol, arguing it needs Kafka for enterprise scale.
Yeah, the core argument there is interesting. It's that if you have lots of different AI agents needing to talk to each other reliably across a big company, you need a communication system that's super resilient, decoupled, meaning agents don't need direct connections to each other, and built for many-to-many communication.
And Kafka provides that.
That's what they contend. That Kafka's publish-subscribe model provides exactly that kind of robust decoupled backbone needed for large-scale agent communication without creating a tangled mess of direct connections.
So across these AI-focused pieces, the consistent thread is practical implementation and scaling of AI agents relies heavily on streaming data and event-driven architectures, specifically mentioning Kafka and Flink. It's very infrastructure-focused.
Absolutely. It moves AI from just algorithms to the actual systems needed to run them effectively at scale. And it really makes you think, doesn't it? How does this shift towards event-driven AI agents fundamentally change what enterprises need from their infrastructure, particularly their data architecture? It suggests a robust streaming platform isn't just a nice-to-have for analytics anymore. It's becoming table stakes for serious AI adoption.
Let's make that even more tangible. There was a specific technical deep dive in the sources about building streaming data pipelines.
Yes, the Building Streaming Data Pipelines, Part 1, Data Exploration with Tableflow article.
Right, and the main thing demonstrated there was using Tableflow, which, we mentioned came up in the Cloud Q2 updates, to turn Kafka topic data into queryable Apache Iceberg tables.
Correct. The sources walk through an example using Tableflow to take streaming sensor data, I think it was UK Environment Agency data, flowing into Kafka and automatically structuring it and landing it into Apache Iceberg.
Iceberg being that open table format for big analytic data sets.
Exactly. So the point is, Tableflow makes that streaming data easily queryable, using standard SQL tools almost immediately after it lands.
So how does this connect back to the bigger picture?
Well, remember the data streaming report saying IT leaders want streaming to unlock data value? This Tableflow example shows how that can happen practically. It tackles the common headache of getting real-time data into a format analysts can actually use easily with familiar tools like SQL. It speeds up getting insights without needing complex, custom ETL pipelines.
So for someone actually building these pipelines,
Yeah, if you're working with data pipelines, the key takeaway here is probably the simplification. Getting data from a streaming source like Kafka into a structured, queryable format like Iceberg, ready for analysis downstream, becomes much more straightforward.
okay, so let's do a quick wrap-up of what we covered from this batch of Confluent sources. We hit the product updates, that managed V2 connector for Cosmos DB, the next-gen control center for self-managed users with performance boosts, and the Cloud Q2 updates focused on batch and stream, featuring Tableflow for Delta Lake and Flink query improvements.
Then we look broader, the data streaming report showing prioritization of streaming platforms to get value from data, and also that interesting piece on async work culture for productivity and well-being.
And then a big focus on AI, how AI agents really need event-driven architectures and streaming data to be effective and scalable, how you can build multi-agent systems with Kafka and Flink, and why Kafka is positioned as essential for that enterprise-scale agent communication, even mentioning Google's protocol. And we finished with that concrete Tableflow example turning Kafka streams into queryable Iceberg tables.
Yep. The goal was just to pull out those key threads and connections from these specific sources, help you get up to speed on what Confluent's been talking about recently. And maybe a final thought to leave you with, building on that AI and event-driven theme that was so prominent. If these sources are right, and the future involves more coordinated event-driven AI agents communicating via platforms like Kafka to run business processes, what does that imply? Does it start to change how we should think about designing not just our tech systems, but maybe even the operational flow of our organizations themselves? Could work start to mirror the flow of events more closely?
Definitely something to ponder. Okay, thanks for joining us for this deep dive.